So today we will solve one question, that is analysis of frame with sway by Kani's method. So this is the question using Kani's method. Analyze the frame shown in figure. So this is the frame. Here the sway takes place. The translation of joint takes place or the sway takes place due to unsymmetrical loading. So here you see the load 33.75 kilonewton present at a distance 2 meters from the joint B and 4 meters from the joint C. So this is your unsymmetrical loading. So the sway of the frame takes place. So here given A, B, B, C, C, D, the length A, B and C, D is you are given 4 meters and B, C length is you are given 6 meters. And the moment of inertia of A, B and C, D is given 2I and moment of inertia of BC is you are given 3I. So what is your first step? So first step to find out the piston moments of the members. So first you consider AB member. So what is the piston moment at the end of the member MFAB and MFBA? So here there is no loading. So the piston moment is your 0. Then take the member BC. So what is the piston moment MFBC and MFCB? So because here this is the eccentrical loading. So you know due to the eccentrical loading how you will find out the moment at the end. So you know what is the formula? Minus W AB square by L square. W is your load and A is the distance, this distance, and B is the this side distance. So minus here this is your minus WAB square by L square. So A is your 2 meter and B is your 4 meter and L is 6 meter. Here minus 33.75 into 2 into 4 square by 6 square. So this is your equal to minus 30 kilonewton meter. Then find out MFCB. Here this is your clockwise. So the sign convention is your positive and W A square B by L square. For MFCB, this is your W A square B by L square. 33.75 into 2 square into 4 by 6 square. So this is your equal to plus 15 kilonewton meter. Then this coming to the member CD. So here also there is your no loading. So what is the moment here? Piston moment. MFCD is your 0 and the MFDC is also 0. The piston moment at the end of the member CD is equal to 0. So this is the piston moments of the member. Then what you have to do? Then you have to find out what is the piston moment of the joint B and the joint C. Piston moment of the joint B. So how you will get the piston moment of joint B? So you know MFBC and you know MFBA. So MFB is equal to MFBA plus MFBC. Similarly, you find out what is the piston moment at joint C. So this is equal to MFC is equal to MFCB plus MFCD. So you find out what is the piston moment at joint B and joint C. So here you see the piston moment of joint B is equal to, this is minus 30. So you know what is the moment here, minus 30, and this side is the piston moment 0. And similarly here you know what is the piston moment here, plus 15, and this side the piston moment is your 0. So you find out here piston moment of joint B and C. So minus 30 plus 0, minus 30 kilonewton meter, then plus 15 plus 0, plus 15 kilonewton meter. Then what is the next step? You have to find out the rotation factors. You have to find out the rotation factor. You know that is how to find out the rotation factor. This is in tabular form, you find out the rotation factor. The first column is your joint and second column indicate this is a member. Then the third column is your relative stiffness of the member. Fourth column is your the relative stiffness of the joint, and fifth column is your rotation factor for the member. So here there is your two joint B and C. So here you take joint B and C, and at joint B, two members meet BA and BC. So here you take member BA and BC. And similarly at joint C, two members meet CB and CD, CB and CD. Then you find out what is the relative stiffness of the member. You know how to find out the relative stiffness of the member. So this is the moment of inertia by length of the member. So for AB, the moment of inertia 2I and the length is your 4, 2I by 4. So this is your equal to I by 2. Similarly for BC, moment of inertia 3I and the length is your 6, 3I by 6. This is also I by 2. Similarly for CB, 3I by 6, I by 2, and for CD, 2I by 4, this is I by 2. Then find out what is the relative stiffness of the joint. So for joint B, show what is the relative stiffness. Show KBA plus KBC, KBA plus KBC. I by 2 plus I by 2 is equal to I. Similarly, find out the relative stiffness of joint C, KCB plus KCD. KCB is your I by 2, I by 2, this is your equal to I. Then after getting the relative stiffness of the joint, then you can find out what is the rotation factor for the members. You know what is the formula. U is equal to minus half into relative stiffness of the member divided by the relative stiffness of the joint. So you know for different member what is the relative stiffness, and you know what is the relative stiffness of the joint. So here you find out U BA is equal to minus half into I by 2 divided by I. So this is equal to minus 1 by 4. Similarly, so rotation factor of BC member is equal to UBC is equal to minus half into I by 2 divided by I. So is equal to minus 1 by 4. Similarly, the rotation factor for member CB is equal to UCB is equal to minus half into I by 2 divided by I is equal to minus 1 by 4. Similarly, for CD member also you can find out that this is also minus 1 by 4. So this is the rotation factors for the members. You have to find out the translation factors or displacement factors. So these translation factors or displacement factors you have to find out for the vertical members. For the vertical members. So here you see only one story. There is 2 columns. In one story there is 2 columns. So column AB and column CD. So here you see you have to find out the story, one story. The story is your 1 here. This is your one story. Member, how many members is your in the story? In first story, AB member and CD member. There is 2 members, AB member and DC member or CD. So what is the relative stiffness of the vertical member AB? You know. So 2I by 4 and the CD member is also 2I by 4. This is the relative stiffness of the vertical member. Then you find out what is the relative stiffness of the this one first story. So in first story there you are having 2 members, vertical members. So you have to find out the relative stiffness of the vertical members. Then you have to find out the sum of the relative stiffness of the all vertical members. Sum of the relative stiffness of the all vertical members of the first story. So in first story there are 2 members. So this is the relative stiffness of the member, and the sum of these 2 is equal to I by 2 plus I by 2 is equal to I. So this is the summation of the relative stiffness of the vertical members of the first story. So after getting this relative stiffness and sum of the relative stiffness, then you can find out what is the displacement factor or translation factor. So this is the formula minus 3 by 2 K by summation of K. So minus 3 by 2 and K is your I by 2 and summation of K is your I. Minus 3 by 2 into I by 2 divided by I is equal to minus 3 by 4. Similarly for DC, UDC is equal to minus 3 by 2 into I by 2 divided by I. So this is equal to minus 3 by 4. Always you have to check in each story the sum of should be minus 3 by 2. This way you can find out the displacement factors or translation factors of the vertical members. Because here one story, if there is a 2 story, then you have to write 2. Then how many members in that 2 story you have to write here. If there is a 3 story, then you have to write 3rd story. Then you have to write the members which is happening in that story. So this way you have to find out the displacement factor. This type of tabular form: story, member, relative stiffness of the vertical members, and the relative stiffness of the sum of the relative stiffness of the all vertical members in the same story. This is your summation of K. So after getting this one, then you have to find out the rotation moments and translation moments. You have to find out the rotation moments and translation moment Then after getting the rotational moments and translation moments, then you can find out what is the final moments. This is the formula already you know in last class already we had discussed. So rotation moment m-12 is equal to u12 into m1f plus summation of m-21 plus summation of m-12. This is the translation moment, and this is the far end rotation moment, and this is the fixed moment of the joint, and this is the rotation factor. So using this formula, you can find out the rotation moments. Then translation moment for vertical members, you can find out m-12 or m-21 is equal to displacement factor or translation factor into the sum of the m-12 plus sum of the m-21. Means sum of the rotational moment of the top end and sum of the rotational moment of the bottom end of the vertical members. Then after getting this translation moment in cyclic manner, you have to find out rotation, translation, first cycle, second cycle, third, fourth. Then after the end, when you get that the same value, you have to stop. Then you can find out what is the final moment. The final moment formula m12 is equal to mf12. Then the twice near end rotation moment. Then one the far end rotation moment. Then the translation moment. So this translation moment is your applicable for the vertical member. If there is a horizontal member, so only have to consider up to the rotation, up to this one. And this you have to include in the vertical members. So m12 is equal to mf12 plus 2 m-12 plus m-21 plus m-12. Similarly, m21 you can find out mf21 plus 2 m-21 plus m-12 plus m-21. So this is the formula you have to use to find out the rotation, translation, and final moment. So this is in tabular form. You can find out. Just I am explain this one. This table. So this is the frame. So there are two joint B and C. You have to make two blocks here at joint B and C. This type of block here. Then so you know what is the piston moment of the joint B. So that you have to put in the inner rectangular block. Similarly, what is the piston moment of the this is MFB and MFC. Then MFC you have to write here this side at the joint C. So inner rectangular block. Then you know what is the rotation factor already. So this is your BA, BC minus 1/4, minus 1/4. Then CB and CD minus 1/4, minus 1/4. So in corresponding block, so this is your BA. So here you have to write this rotation factor. Then this is your BC. So here you have to write the rotation factor minus 1/4. Similarly, for CB, here you have to write minus 1/4. And the CD, you have to write the rotation factor minus 1/4. Then you know, already you know what is the piston moment of the end of the member. So this green is the piston moment of the end of the member. So MFAB, MFBA is your 0 piston moment. And the MFBC you got minus 30. And the MFCB you got plus 15. And the MFCD is also 0. And the MFDC is also 0. This is the piston moment of the end of the members. Then you know here you got what is the displacement factors or translation factors of the member AB and DC. Here the displacement factor or translation factor for member AB is your minus 3/4, and for member vertical member DC is your equal to minus 3/4. Just to write here. So for AB member displacement factor, just to write this is the vertical member, just midpoint of the vertical member. You made one rectangular block. So in that rectangular block, you write, so what is the displacement factor? So just this is the vertical member. So this is the midpoint. So at midpoint, this is the rectangular block. And here you write minus 3/4. And for CD also, here you write minus 3/4. So always for the vertical members and the translation or displacement factor, you just enter in the midpoint, central point of the vertical members for AB and CD. Then what you have to find out, this is the displacement or translation factor. Then you have to find out the rotation moments and translation moments. These are the rotation moments. So you have to enter the M-BA rotation moment, then M-BC rotation moment, M-CB rotation moment here, then M-CD rotation moment here. And this is the translation moment. You have to enter the translation moment in the vertical members. Inner side, you can write this one, translation moments. This is your M double dash AB. This is your M double dash CD. This is your M double dash AB or M double dash BA. Because the translation moment M double dash AB or M double dash BA is equal to same. So this is the translation moment you have to enter in the vertical member, just mid portion, here and here. For CD, here you have to enter the translation moment. First you go for the cycle 1 and go to the joint B, and in joint B you have to find out what is the near end rotation moment, M dash BA and M dash BC. So you know the process, M dash BA and M dash BC. The near end rotation, when you will find out the near end rotation moment, you have to take the far end rotation moment, because this is the end which is fixed. So what is the rotation moment here? 0. The far end rotation moment here is 0. And here also, so you have to assume the far end rotation moment is your 0 here. Other end, you have to assume that is your 0. And you know what is the piston moment of the joint B? To assume the translation moment is also 0 in first cycle. Then you can find out what is the near end rotation moment. So here you see cycle 1, rotation moments, joint B, assume all far end rotation and translation moment to be 0. Far end rotation and translation moments. Far end rotation here, and the translation moment is also 0. M may be sum of fixed end moment, you know, minus 30, and this is summation of M dash AB, rotation moment of the far end of member meeting at joint B. We know M dash AB is equal to 0 as A is your fixed. Due to A is your fixed, and M dash AB is equal to 0. And M dash CB is your assumed rotation moment is 0. M dash CB is your the rotation moment far end is your 0. And M double dash, this is your M double dash AB. This is also you have to assume 0. Assume translation moment is your 0. So this is the formula. This is the formula M dash BA. The near end rotation moment you have to find out. So rotation factor into the fixed end moment of the joint B plus the sum of the far end rotation moment plus the sum of the translation or displacement moment of the column which is meeting at joint B. Similarly, M dash BC is your UBC. So here this is your not required. Here only have to take, because here there is your the translation moment is your 0. For this member, for horizontal member, when you will find out the near end rotation moment of the horizontal member, so here this translation moment you have to take 0. M double dash BA is equal to 0. You have to not take this one, because only this is applicable for the vertical member. When you will find out the near end rotation moment of the vertical member, so that case you have to take the translation moment, sum of the translation moment of the vertical member which meet at the joint B. But in the case of this horizontal member, so there is no need to take the translation moment. So this will be 0. So here you find out M dash BA is equal to minus 1/4 rotation factor, and MIB you know minus 30, and the far end rotation moment and far end translation moment is equal to 0, 0, 0, 7.5. Similarly, M dash BC is equal to M dash BA you got, and M dash BC is equal to minus 1/4 minus 30, 0, and the translation moment here, this is not required, 0, 0, and this is also 7.5. This is also 7.5. So just to enter here 7.5 and 7.5. So you got joint B, what is the near end rotation moment. Similarly, go to the joint C and you find out M dash CB and M dash CD. When you will find out M dash CB, so the far end rotation moment, this side you have to take plus 7.5 and this side you have to take 0 due to fixed end at joint D. So go to the joint C, sum of fixed end moment here you know plus 15. Sum of fixed end moment here you know plus 15. And rotation moment at B you have to take plus 7.5. Rotation moment at B you have to take plus 7.5, the far end. And rotation moment at D you are 0 fixed end, and displacement moment of column CD you are 0. You have to assume the displacement or translation moment of this column is 0, because at joint C, so this is the vertical member meet at the joint C. Displacement moment of this column you have to assume 0. CD you assume 0. Then you find out M dash CB and M dash CD. you find out what is the M dash CB and what is the M dash CD. M dash CB, that is your 15 into minus 1 by 4 plus 7.5 plus 0 and plus here also 0. Plus 0 plus 0. So this is your minus 5.63. Similarly, you can find out M dash CD you are equal to minus 5.63. Because this is your here this is your M dash CB, there is your known translation moment is your 0, and that in first cycle here also this is your 0. So minus 5.63 and minus 5.63. So here you enter minus 5.63. So now the rotational moment of joint B and joint C you got. Then you have to go find out the translation moment. Then you can find out what is the translation moment in first cycle. This is story 1. So here there is your how many story? One story. So for story 1, you find out what is the translation moments. So there is only one story in the present case. So rotational moment at the top of the column AB is your plus 7.5. You know what is the rotational moment here? Already you got plus 7.5 the rotational moment, and this side the rotational moment is your 0 for AB. Similarly for CB, you got the at the top of the vertical member the rotational moment is your minus 5.63, and at bottom the rotational moment is your 0. Rotational moment at top of the column AB 7.5 kilonewton meter. Rotational moment at the bottom of the column AB 0 piston. Rotational moment at the top of the column CD minus 5.63. Rotational moment at the bottom of the column CD 0. Then this is the formula: M double dash AB is equal to M double dash BA is equal to new AB summation of M dash AB plus summation of M dash BA. Means this is the sum of the rotational moment of the top of the column, and this is the rotational moment of the bottom of the column. So here you see, so at top 7.5 and minus 5.63 top, and bottom 0 0, and the displacement factor is equal to minus 3 by 4. This is the displacement factor, new AB displacement factor. So M double dash AB is equal to minus 3 by 4, 7.5 minus 5.63 plus 0 plus 0. Similarly for M double dash CD also you have to find out using this formula: minus 3 by 4, 7.5 minus 5.63 plus 0 plus 0. So only in translation moment you have to take what is the rotation moment you got in the vertical member at top and bottom, that you have to consider, and you have to take the sum of the rotation moment of the top end plus the sum of the rotation moment of the bottom end. So this is the value, and this is the after summation of this. So you got here M double dash AB is minus 1.40 kilonewton meter, and M double dash CD is equal to minus 1.40 kilonewton meter. This value, the translation moment, you have to put here. So this is the first translation moment, and this is also the first translation moment. So now the first cycle is over. So here you got the rotation moment 7.5, here 7.5, 5 minus 5.63, minus 5.63, and for the vertical member you got the translation moment here. Then you go for the second cycle. So in second cycle you go first go to the joint B. Again you find out the second cycle value, rotation moment. So when you find out the second cycle value, so you have to take the far end rotation moment. This side is your minus 5.63 and this side is your 0. And you have to take the translation moment is your minus 1.40. Because in first cycle you have assumed that is the 0, the translation moment, but when you will find out the rotational moment of the near end, so you have to consider the translation moment of the first cycle, what you have already calculated. So you have to consider this is the minus 1.40. Then you go for joint cycle 2. So first you find out rotational moment. So sum of piston moment already you know minus 30, and rotational moment at A 0 due to piston, and rotational moment at C is your minus 5.63. So what you got in the first cycle you have to take minus 5.63. Then displacement moment of column AB already you know minus 1.40. Then you put this value and find out M dash PA minus 1 by 4 minus 30 plus 0 minus 5.63 minus 1.40. This is your 9.26. Similarly, M dash BC is also minus 1 by 4 minus 30 plus 0 minus 5.63 and minus 1.4. This is your 9.26. Then go to the joint C. So similarly, you find out what is the M dash CB and M dash CD. So this is the rotational moment. 9.26 you have to take this side, and this side you have to take 0. This side you have to take 0. And you have to take the translational moment is your minus 1.40. What you got in the first cycle. Sum of piston moment plus and rotational moment at B is your plus 9.26. In the second cycle, what you got, you have to take this one, this value, 9.26 second cycle. Then rotational moment at D is your 0 fixed, and the displacement factor moment of column CD you got this one. Then you put M dash CB is equal to minus 1/4 this value. So this is your minus 5/72, 5.72, and M dash CD is equal to minus 5.72 kilonewton meter. Then again you find the story on translation moment. There is only one story in the present case. The rotational moment at the top of the column. So you have to take here, when you find out the translation moment in the second cycle, so you have to take what you got, the rotational moment in the second cycle, that you have to consider. 9.26, this side is 0. And here minus 5.72, and this side is 0. That you have to take the sum of this, the top end rotational moment, and sum of the bottom end rotational moment into the displacement factor. When we find out for this vertical member into minus 1/4, and for this vertical member is also minus 1/4, and you have to put here in second value minus 2.66. Here, so this is 9.260, and rotational moment at top of the column CD minus 5.72. Rotational moment at the bottom of column CD 0. M double dash AB is equal to minus 3/4, 9.26 minus 5.72 plus 0, this one. And M double dash CD is equal to minus 3/4, 9.26 minus 5.7. This is your minus 2.66 kilonewton meter. Then you go for cycle 3, and again you find out what is the rotation moment. So when you find out a rotation moment, so here what you have to do. So in third cycle, you have to take, this is the value, the translation moment, you have to take minus 2.66, and the far end rotation moment C, you have to take minus 5.72, and this side you are 0. So what is the value you got in the second cycle? That you have to consider for third cycle near end rotation moment, M dash BA and M dash BC. M dash third cycle, M dash BA is your minus 1/4, minus 30 plus 0, and minus 5.72. In second cycle, what you got here? Minus 5.72. Minus 5.72 per end. And here in translation moment, you got minus 2.66. Minus 2.66. So find out M dash BA. Similarly, you can find out M dash BC also. Minus 1/4, minus 30 plus 0, minus 5.72, minus 2. So this is also 9.60. Similarly, go to the joint C, and again you find out M dash CB and M dash CD, and you put in the value here. So this is 9.60, 9.60, and at joint C also the value is minus 5.49, and this side also minus 5.49. Then you find out the translation moments of the vertical members in cycle 3. Cycle 3, rotation over then translation moment. So when you will find out the translation moment, M double dash AB or M double dash CD, so what is the value you have to take? What value you got in the second cycle, the rotation moment of the top end of the vertical member, that you have to consider. And bottom end, that is your 0 due to fixed, and you have to consider the top 9.60 minus 5.49. Here you got this value 9.60 minus 5.49. What you got in the third cycle, that value you have considered to find out the translation moment of the vertical member in the third cycle. So this third cycle rotation moment you have to consider. Plus 9.60 minus 5.49, and this side 0 and this side 0. So here you got this value here minus 3.08. M double dash AB is your minus 3.08 and M double dash CD is your minus 3.0. Cycle 3, translation moments. Then again you go for cycle 4. Then you find out what is the rotation moment. So M dash B is equal to minus 1 by 4, minus 30 plus 0, minus 5.49, minus 3.08 is equal to 9.64 kilonewton meter. And M dash BC is equal to the same 9.64 kilonewton meter. Similarly, at joint C, minus 1 by 4 into 15 plus 9.64 plus 0 minus 3.08 minus 5.39 kilonewton meter. So you put this, and for CD also the same 9.64 and minus 5.39. 9.64, 9.64 and minus 5.39 minus 5.39. Then again you find out the translation moment and you put in the vertical members. This is the story 1 translation moment. This is your minus 3.19. So here you put this translation moment. Minus 3 point, this is for 4th cycle. Again in the similar way, you find out for 5th cycle, what is the rotation moment and what is the translation moments. Here you see in 4th and 5th, there is the difference is very less. That is your 0.01. Very less. So just you stop here and you take the 5th cycle rotation moment or translation moment is the final rotation moment and translation moment of the members. So here M dash BA you take 9.65 and M dash BC you take 9.65, M dash CB you take minus 5.37 and M dash CD you take minus 5.37 and M dash AB you are 0 rotation moment and M dash DC you are 0 rotation moment. These are the rotation moment. And the translation moment M double dash AB is equal to M double dash BA is equal to minus 3.21. Similarly, M double dash CD is equal to M double dash DC is equal to minus 3.21 kilonewton meter. That you have to consider for calculating the final moment. So this is the final moment. So this is the formula. So the formula is your MAB is equal to MFAB plus twice into M dash AB plus M dash BA plus M double dash AB. In vertical member, you have to consider only the translation moment, but in horizontal member, there is no need to take the translation moment. When you will find out the final moment, so this is your not required. This is your not required. The translation moment. So MAB, MBA. You see, MFAB is your 0. You know, Piston moment at joint A 0 and 2 M dash AB rotation moment is also near 0 and far end rotation is your 9.65 and the translation moment is your minus 3.21. So this is your MAB. Similarly, MBA is equal to MFBA plus twice M dash BA plus M dash AB plus M double dash BA. So here MFBA is your 0 and twice M dash BA you got 2 into 9.65. 9.65 this one. 9.62 into 9.65 and this side is 0 and the translation moment is your minus 3.21. 2 into 9.65 plus 0 minus 3.21. This is your 16.09 kilonewton meter. So you got MAB and MBA. Similarly, find out for horizontal member MBC and MCB. MBC, MFBC plus twice M dash BC plus M dash CB. So here you know MFBC is your minus 30 and twice M dash BC is your 2 into 9.65 plus M dash CB is your minus 5.37. So this is your equal to, so here no need to take the translation moment. So this is your equal to minus 16.07 kilonewton meter. Similarly, MCB, MFCB plus twice M dash CB plus M dash BC. So MFCB you know 15 plus twice M dash CB 2 into minus 5.37 and this is your the far end 9.65. So this is your 13.91 kilonewton meter. Then similarly MCD is your, this is MFCD plus twice M dash CD plus M dash DC plus M double dash CD. This is the value. Here you have to take the translation moment, and here also you have to take translation moment. So this is minus 13.95 and this is your minus 8.58. So these are the final moment. Then here you see this is your same value, because you are getting some error in calculation error, this one. So 13.91, this is 13.95. So this is almost same. And here also this is your, because our joint C, so that should be the moment, the sum of the moment should be 0. So here this is your 0. So here you take anyone 13.91 at joint C. So this is the moment here. So then this is the direction of the moment. MAB you got 6.44. So this is clockwise 6.44. Then MBA, this is 16.09 positive clockwise. Then this is MBC minus 16.07. This is also anti-clockwise 16.09. Either 07, 09 or 08 you can write here. Then MCB here you got 13.91 clockwise, and MCD you got minus 13.95. So this is, so right here 13.91 or 9 or take average of these two. Then DC MFDC your minus 8.58. So this is your negative anti-clockwise. Then according to this direction you can draw the final bending moment diagram. So here the final bending moment diagram, because here this side you have to take 6.44, this side is your 16.09, then you have to join this one here 16.09, 6.44, join this one, this portion negative and this is positive. Similarly here this side is your 16.09 and here this is 13.91, and you have to join this line. This is a negative bending moment, 16.09, 13.01, this is your negative. Similarly here 13.91 and this side is 8.58, 13.91 and 8.58, and you have to draw this line. This is negative portion, this is positive portion. Then you know this is the load you are having on the span BC. So what is the free bending moment diagram? Because here there is a load. So what is the free BMD? Triangle. So what is the moment? The maximum moment at the loading position? WAB by L. You know, if the eccentrical loading is there, so what is the moment at the loading position? WA into B by L. Free bending moment on span BC, W into A into B divided by L6 is equal to 45 kilonewton meter. So this is your 45 kilonewton meter. Here you can find out what is the maximum positive moment, because here this is the positive moment diagram and this is the negative moment diagram. This portion is your cancel each other. So only this is the remaining portion negative, and this remaining portion is your negative, and this is the positive portion. So you have to find out what is the maximum positive moment at the loading position. Here this moment you have to find out, or how to find out the maximum positive moment. This ordinate by making that triangle. So you can find out this value, and you know this one. So this total you can deduct this total is your 45. From this 45 you can deduct this portion, then you'll find out what is the maximum positive moment at the loading position of span BC.